Derivatives of carboxylic acids can be formed in the laboratory, and we're going to take a quick look at how these reactions occur. We'll look at these reactions in more detail later in the chapter. So on the left-hand side, we have the carboxylic acid, and highlighted in red is the hydroxyl group. When carboxylic acid undergoes these reactions, which are sometimes known as condensation reactions, but your textbook calls them carbonyl group substitution reactions, it is always the hydroxyl of the carboxylic acid that is lost, and another group comes in and takes the place of that hydroxyl. Now the hydroxyl of that carboxylic acid always reacts with another hydrogen to form water, and then, of course, the carboxylic acid derivative. So we have the carboxylic acid on this slide reacting with a variety of different chemicals, all of which have hydrogen, and the first one listed here is going to be an alcohol. This hydrogen bonded to an OR group is an alcohol. The hydrogen from the alcohol, which is bonded to the oxygen, reacts with the hydroxyl group from the carboxylic acid to form water, and the remaining part of that alcohol, the O and the R group, bond to the carbonyl carbon to form an ester. When ammonia reacts with carboxylic acid, one of the hydrogens from ammonia reacts with the hydroxyl group from the carboxylic acid to form water, and the remaining NH2 bonds where that OH was to form a primary amide. When a when a primary amine reacts with a carboxylic acid, one of the hydrogens of that primary amine reacts with the hydroxyl group on the carboxylic acid to form water, and the rest of that primary amine bonds where that hydroxyl group was to form a secondary amide. And when a secondary amine reacts with a carboxylic acid, that it only has one hydrogen, and that one hydrogen on that secondary amine reacts with the OH on the carboxylic acid to form water, and the rest of that secondary amine attaches to that carbonyl carbon where the OH was to form a tertiary amide. And esters can be easily made in the lab. We would have made this in the lab if we were still meeting face to face. And it's important to know how this reaction works to name esters. So as I said, we'll look at these in more detail later in the chapter. But we need to know that when an ester forms from a carboxylic acid and an alcohol, the carbonyl and the R group bonded to that carbonyl always come from the acid. And the O bonded to that carbonyl carbon and the R group bonded to that O always come from the alcohol. So this is another example of the substitution reaction that we saw earlier. Water is always formed, and we can also look at the opposite of forming these carboxylic acid derivatives. And the opposite of forming these carboxylic acid derivatives is known as hydrolysis. So this larger molecule that was formed reacts with water to form two smaller molecules. So the two small molecules that reacted together to form the carboxylic acid derivative. So we'll always get our carboxylic acid back, and then the other molecule that reacted to form the larger molecule.